I think this one falls down.
It's my best friend. Good luck. You will need it. I didn't do it, Deepa did. I didn't do it, Deepa did. Yeah, so last week's code did the my items.print work for you? Did you even try it?
When it works, I will be the
Okay. This one. This one. No, not that bit. I've done that ages ago. I'm talking about my items, not items, my items. That's the last one. That's the last one. Yeah, last week's.
Sit wherever you want. Yes.
Yeah. What's the name again? Pictures. He's taking videos. We did.
Okay, let's
Don't see it properly.
The example we did last week.
Osman,
And remember what we were doing?
you're coming in the way. Yeah.
Looking at container class. And I brought down that little box of DVDs, or sorry, CDs, floppy disks, and sort of illustrated putting things into a container. We said there were lots of other examples of container this room, a file on disk, a folder, a form in Windows. All these are examples of containers in which you place other objects. And so we're going to produce this container class called, I've given it the name, my items, but it's classes items. And we use the plural to show that it's a container class. I'm not going to do a tremendous amount today, because I don't want to make you sort of brain dead for your assignment. I keep coming in with a bit of luck, we might have some time for some practical later on. But what I want to do to start with is, you remember when we did Visual Basic? Then all the time I was drawing little pictures of memory on the board and showing what happens when you say an assignment statement, you say A becomes equal to B, what actually happens at runtime. It's going to be even now more important that you draw these little pictures to show what's happening at runtime, because what's actually happening isn't what perhaps you think is happening. Now I'm going to use this example just to show what's happening in the Visual Basics way of doing it first. If you had a variable called A in Visual Basic, and that had got, I don't know, 5 in it, and another variable B with 3 in it, and you said A becomes equal to B. And fairly recently, you would take the contents of B and place it into A, and you'd get that. Let's make this slightly more let's this time, let's assume this was a structure where it had an ID, apples, a name and a price, and another one B with an ID, apples, and ID, name and price. And I said B becomes equal to A. It would take the entire contents of A and shove it into B. And so then you get 1, 1, 1, 1, 1, apples, 10. In other words, it's taken the entire contents of the structure and moved it to the other one. What happens, of course, is always it takes the contents of that and places it into there. In Java, this isn't the structure that you get when you construct objects. We take that statement here, item becomes equal to new item. And what's supposed to happen is it constructs a new item object, and there it is in memory with a reference number, a name, and a price. Remember, that's the default constructor. And remember, our default constructor is there. And so it sets the reference number, name, and a price to question mark, question mark, question mark, question mark, name, no name, and price is 0. Let's come back to my items test. So that statement has constructed me this object with the default parameters, and it's assigned it to this variable called item. Now what's actually happened here, Java has created a variable called item, and in that variable item it's actually put the actual runtime address of this structure over here. This didn't happen in Visual Basic. If this had been Visual Basic, I'd have written the word item there. And let's just fiddle around for a little while. Let's say this was called item 1, and I had another variable called item 2. If I now say item 2 becomes equal to item 1, it does exactly what Visual Basic would have done. For A and B, and that's got 5 in it, and that's got 3 in it, and I'll say A becomes equal to B. It takes the contents of B and places it into there. 3. If I say item 2 becomes equal to item 1, it takes the contents of item 1 and places it into there. What's the contents of item 1? It's not that. The contents of item 1 is that. Now I like to think of this as a sort of a drawing pin, and that as an elastic band. And that's stuck on there. And so if I say item 2 becomes equal to item 1, it's going to take a copy of that drawing pin and place it in there. So item 2 is pointing at the same object. We haven't got 2 copies of the object. Both of these pointers are pointing to the same location. If later on I was to change item 1, for example, I said item 1 dot set reference number to 2222, and item 1's reference number would get changed to 2222, and item 2's reference number is also changed because they're both pointing at the same object. Think if here's an object One person points to it, another person points to it, both people are pointing at the same object. And if I move the object or change the object in any way, both people are still pointing at that object and see the changed one. So whereas here in Visual Basic, it would have got a complete new copy, and one of them would have been 1111 or question marks, and the other one would have been 2222. It's now pointing at the same object. If we take this example to actually see what's happening at runtime, and I'm afraid the lines get rather a mess here when we try and draw these pointers around. That statement is going to construct me a new container. So here's my container. And the name of the container is items. And that's pointing to it. Here's all the elements in my items container. Here, I'm declaring a variable called item. It's of the class item. So that just declares a single variable called item. At the minute it has no value. Here, item becomes with a new item. That's the bit that's going to construct me an item object. The properties are going to get set to their default values, and then I'm going to assign what's called a reference to that object for this variable called item. So a reference to that gets stored in there. And of course, this has all the default values in, question marks, no name, and 1. We then say item 1.ask into details, and the user is going to say 1111 apples 100 or whatever. So 1111 apples 100 gets stored in there. And then we say add item to my items. The contents of item is that value in there. So when that value gets added to the container, it doesn't take all that chunk and move it in. It just takes that value there and places it into there. So in effect what we now have is that. So this could be a huge great chunk of memory with loads and loads of data in it. But that assignment statement has happened very, very quickly, because all it's done is just move the pointer, it hasn't actually moved the object itself. So we're done down to there. Now we obey this statement, says item becomes equal to new item. So we're going to construct a new item object. Set the default values, so it's going to be question marks, no name, 100. And then assign the reference of that to the variable called item. So that value item is going to get destroyed, and the new one is going to go into there. And now we say item.ask, and so this time the person types 222 bananas or whatever. So here's the 222, and there's the bananas, and there's the 200. And now when we say my items.add item now, there's item, so it's going to take that value and add it to the items. So that drawing pin's getting plugged in there. So now we're getting that. And in a moment when we construct the next one, again, there's the 333 comes in there, and then we add that to the container. It's that value that's gone, in. When your programs go wrong, as indeed they will, and you're trying to suss out where they've gone wrong, rather than just sort of have lots of little boxes as you would have done when we did Visual Basic, what you will have is a structure such as this. And you're going to have to draw it to try and suss out where your program's gone wrong. And if you come up to me and say, my program's gone wrong, can you help me? I'm going to want to see something like this on a piece of paper in order that I can help you. I don't expect to be able to have to do it all to myself from scratch. So try and get into the habit then, whenever you construct these objects, construct them and always remember that you get a reference to this thing, you don't actually get the value itself. Okay, let's just extend this at the minute. What we wanted to produce was a menu-driven application that would allow the user to say, I want to add a new item, I want to display all the items, or I want to display a particular item in the box. So let's change this to a menu-driven application. So let's start a new application. And what I'm going to do is take this and fiddle around with it. So I'm not going to start from scratch, and as I say, this is all on the internet, so you can get a copy of it anyway. It's all in the sample programs or in the tutorial and the workbook itself. So, let's file, new. Oh, sorry, I didn't want to file new. I wanted to add.
Yeah.
Sorry?
So you first before you start filing new doing prep.
New project.
That's a new project.
I can't
You just
do
press
anything.
cancel.
I can't do anything in a minute.
Minimize it. You minimize the window.
I can't do anything. I'm saying.
How come he's get task manager?
Yeah, so cancel.
Okay, so let's, we're going to create a new Java program. We've got item 1 test, item 2 test. So this is going to be my menu-driven application. I'm going to call it shop version 1. So, shop version 1 dot Java. File doesn't exist, create the file, yes please. So there's shop version 1. And so you're not going to be able to do this because I'm going to do a big copy. So I'm going to just copy item test. Copy it all. And paste it into shop version 1. Just to save me messing about too much. Shop version 1. I think I missed the word. I missed those first 2 lines off, didn't I? There we go. Edit. Copy. And so it's not called items test anymore, it's called class, which I think given a capital letter. So it's shop version shop B1. This is shop B1. I'll save all. Let's just check and see if this runs. So shop B1, run. And come to that. So this is shop version 1. Enter reference number 1111. Enter name AAAA. Price 100. Enter details again 2222. DDDD 200. Third one. And we get more printed. So now what we want to do is change this into a menu driven application that will just keep going on and on and on and on and on. Delete these items. Fine, so now what I've got is a container, and the container has been constructed. So I've got a big container that I can add these things to. Now what I want to be able to do is allow the user to have an option to be able to add something to the container, add as many things as they like to the container. Let's now again, I'm going to work around to do. You're going to have very great difficulty if you're copying this down. So I'm going to work backwards and forwards all over the place. I want a loop going on over and over again. So I need a while loop. That's the syntax for a while loop. It's the word while, followed by the condition, followed by the statements that we want to execute within the brackets. Let's think how I'm going to drive this thing. I want a menu. Now you can display a menu in lots of different ways. We've got a fairly small screen, so we want to display the menu as compactly as we can. And before Windows was invented, the way most computer applications display the menu was to just display a single letter, F for file, and then it would say ILE, so it would be F close bracket ILE, telling the user that the option that they've got to choose is file. Well, eventually we'll be able to file these away. Options is our user going to have at the minute. They're going to have an option to add an item to the container. They want to be able to print all the container. So we'll have it says print. If they type add, it's going to ask them to enter the details, so it's added in. P will print the container at any point, and later on we're going to have save and whatever, all these other options. When the person gets bored with the whole thing, they want to quit the application. And so usually the last one, if you have menus like this, is called quit. And normally we would say enter option before that. So the user then decides what they want to do. And you think what's going to happen is that the user is going to have to enter either A, P or Q. So if they hit A, and then they're going to hit the enter key, or P or Q, or perhaps the user might hit lowercase a. I don't want to say that's an error, because obviously what they want to do is add something. So what I'd like to be able to do then is read what the user enters, the first character, and regardless of whether it's uppercase or lowercase, I then want to compare it with A, P or Q. And if it's equal to A, we're going to add P, print, Q, whip. So this is something we want to do quite frequently. There's not a a function that will do it for us that I've set up in that string IO package. Let's not worry about the condition in there at the minute. The name of the function that you're going to use, it's in string IO. And it's called read menu option. The read menu option accepts as a parameter, as you can see, the menu, and this is the menu. It's a string. So the menu that I want to display is a close round bracket, add, P, close round bracket, int, or Q, close round bracket, width. So there's the options that get displayed. What this function will do is display that on the console and sit and wait for the user to hit the key and the enter key. If the user types more than one character, it will just take the very, very first character and it'll take that character and convert it to uppercase for you. So regardless of whether the user types lowercase or uppercase, the value will be returned in uppercase. So basically what we want to do is take the character that the user has entered and save it somewhere and in the notes. Call that option. And the sort of variable the option is a character. It's come up. I'd like to declare it. There's two places I could declare it. I could declare it inside the loop, or I could declare it outside the loop. If I declare it inside the loop, then every time we go around that, it's going to declare a variable over and over and over again. I only want the variable declared once, so I'm going to declare it right at the beginning. Option. Declared the variable, now I don't need to declare it inside the loop. If I did, it would be declared over and over and over and around the loop. So, this loop wants to continue all the while. To stop this thing going, the user is going to type Q for quit. A nice little device for having this effect is to have another variable, call it whatever you like, but I'm going to call it finished, which is going to be a Boolean. And the variable